Hello, everyone. Welcome to the next edition of the Daily Coding Challenge, where the word daily is very badly named, but naming is one of the big problems in computer science. Let's get started. I'm going to pick a random hard problem on LeetCode that I've never seen before, and I'm going to solve it in real time while walking you guys through my thoughts. I don't have a subscription, so I can't use that. Unique paths 3. I don't know if I've already done that one before. Let's look. Yep, unique paths 3. I've done that before. Reducing dishes, I've done that. Recover a tree, minimum number of flips. Maximum score words formed by letters. I'm pretty sure I haven't done that one. Let's give that a try. Have I done this one before? I might have actually done this in an interview, but I don't remember right now. Single words under repeating, score every character. Turn the map. Boggle, concordance. Yeah, I don't think I've done this one. Okay. This is the one that we're gonna do, guys. Let's take a look. So you have a list of words and also a list of single letters and a score for every character. And you can only use a word once. Each letter can only be used once. You don't have to use all the letters. Okay. So it would have been ideal if they give us a map of a letter to score, but they didn't. What they've given us is a map of letters, a list of letters and a list of scores. So you just gotta use the index to make it happen. Dad and good. Okay. So I guess it's kind of like Scrabble. You gotta make sure you use your letters to form words that are the highest possible score, and you can only form the words given in the words dictionary that they provided. Okay. I guess right off the bat, one thing you can do is to just rule out any word that can't be formed using the letters that you have. So that's one way that we can do this. And you gotta make sure you can only use the letter once. X, BX, and CX. Okay, so I guess this shows that you can't just pick the highest scoring word every time, because using a combination of lower scoring words could actually give you a better score than just picking the highest scoring word. Okay. So let's think about this. I think the approach that we're going to do is that we're going to start off by saying, first delete any word from your list if it cannot be formed using the letters that you have available. And that gives you the list of candidates. And out of all the candidates, you start off with the first candidate and you decide, okay, am I going to form this word? And if I'm not going to form this word, then move on to the next one. And essentially, you want to basically cover both options. Like, either you form the word or you don't form the word. And if you don't form the word, then you move on to the next one and you decide, okay, what is the remaining score if I don't form this word? Whereas for the case where you do form the word, you can actually remove the letters that would be required to form that word. And then you recursively ask, okay, what's the highest score that I can get from this? from the child branch. And once you've computed the highest possible score on both branches, then you can pick the higher score, and that will be the return value that you provide. So let me illustrate this. Let's first create a package. I'm just going to call this Scrabble, because it sounds a whole lot like Scrabble, doesn't it? Scrabble. There is my Scrabble. There is my Scrabble. Scrabble test. All right. Let's first create the definition, shall we? Public static. You have a list of string, which is a word. Yes. A list of character, we'll call this letters, and list of integer scores. Okay. Scrabble dot. This seems very weird. Why is it not finding it? Ah, I think I see what's going on. I put this one in the test, which is very dumb on my part. Sorry for the holdup with this very, very boring and tedious mistake that I've made. We should hopefully get started very soon. Oh god, what is going on now? Let's rename this file, refactor, rename, Scrabble test. Perfect. Finally. Okay. You know what? I am just gonna make this a string. just so I can make this copy paste not very, very painful. If this was an actual real world production problem, I would want to use a character, but this is not a real world problem, so I don't care. Let's just do what is more expedient for now. Next score. $23. Cool. All right. Let's copy all of this over. Example 2. Letters. And scores. I actually just realized something. You're actually not supposed to use the index. You're supposed to use the character. So for example, the score for Z is not 4, the score for Z is actually 10. Yeah. Okay, cool. 27. And the score here is 0. Alright, let's run the test, make sure they all fail for the right reasons. And I'd be very shocked if any of them succeed. In fact, I would say it is almost impossible for them to succeed. Cool. Okay, so now let's actually make this work. And right off the bat, I think that what we need is a optional integer get score. Actually, you know what? Do not need optional, just an int get score for a string word. And you know what? These are actually kind of immutable, aren't they? Actually, no. We're gonna have to reshuffle the letters every single time. So that would be a pain. But I guess the scores could be kept the same. So let's do that. Private final list of scores. Fun fact about a mutable list or copy of, if you pass in a mutable list as an input, it will actually not make a copy. So that's actually pretty performance efficient, and it's good to make a defensive copy. So this one is going to do You might be wondering why I'm doing all this. It's just because I don't want to pass in this list of integer scores every single time to all the recursive calls. That is just a big pain, isn't it? So that's really the only reason why I'm doing this. It just looks messy, and I do not like it when things look messy. And in fact, yeah. So this method is just gonna not even check for availability, it's just gonna get you the scores, all of them. So score equals 0 for okay. I'm pretty sure this can only give you lowercase letters. So it's probably a cleaner way to do this, but what we can do is to do index equals letter minus a. Okay. Essentially, if the letter is a minus a will give you 0, and then you go to 0th index. If the letter is b minus a, I believe, according to Java, should give you an index of 1. And so then you will look up the list for index 1. So there you go. And you do this for every single letter, and then you return the score. Now let's also create a new method for private static can word be created. And this one, it's not going to check for score, it's just going to check for do I have the tiles available to create this word. So we have the word. Let's give it the list of letters. Oh, I gotta be careful with set. Okay, so I'm actually going to combine this into a single remove letters, which will return a optional. If it was successfully removed, it will return optional of non-empty value. If it cannot be removed, it will return a empty. And this will return you a list of string. Cool. Okay. So the reason I'm doing this plus thing is to convert a character into a string. Actually, you know what? I'm gonna do it right now. I'm gonna use a... Nah. Shit. I'm not gonna do it right now. It's just too much work. I'm sorry guys, but I will go through this at the end just to explain the idea that I have in mind. Let me remind myself about how remove works. What does it return? So it returns true if it contains a specified element. Okay, now let's return optional.off letters updated. Cool. Okay, so if there's no words given, you can't build anything, so then you just return 0. This will be our terminating condition. Otherwise, we pick a candidate. Um, candidate and letters. If a letter is removed, dot is empty. Huh, why is this giving me an error? If it is not present, I just return the score without candidate. Otherwise, if it is present, then int score with candidate equals get max score birds letters removed dot get plus get score for candidate. Okay. I guess to some extent this is a brute force solution because we are exploring every single possibility that can exist. Um, though there are some speed ups that we can do. So to do store. In fact, that is something we should do. Yep, I think we should definitely do that. So private final map of string to score. Yeah, there's no such thing as score. It's an integer. How silly of me. Come on, IntelliJ. Let's import the map. This is something you should always know. If word score start contains keyword, then return word scores dot get word. Integer. Because this could be null, so I have to use an integer object, not just a primitive. If cached is not null, return cached. Okay. Word scores dot put word score return score. Great. This makes it a little bit more efficient. New Scrabble scores dot get max score, given words and letters. Okay, let's see how we do on this one. I think it's never gonna work on the first try, but we'll see how and what bugs this produces, and based on that we can fix it. Unsupported operation. Oh, okay. So I need to make a copy. Okay. So my words is gonna be new linked list. Okay. And my letters are also gonna be list.new linked list. Yeah, I think a linked list is better here because we never look up specific indexes and we're gonna be removing stuff constantly, so okay. Interesting. I got the third one. I guess this is the easy one because I should get 0 because no words can be formed. Expected 23, but it was 12. How did I get 12? Okay, so I'm getting one of the words, this one, but I'm ignoring the first one. Dad and good. Okay, so I'm ignoring the one that's closest. Let's see if I'm not returning something somewhere. Get max score. I see the problem. Oh, actually, no, wait, I don't. Okay, so what I'm doing now is just making sure there's no collisions between different calls. So the scheme that I decided on was that the parent is never going to trust the caller. I mean, the caller is never going to trust the callee. So anytime the caller cares about maintaining integrity, it has to make a copy of it. So that is the new invariant that I'm working with. So over here, when we call getMaxScores, we have to make a new copy of words because it will be reused later. Similarly for letters. For remove letters, well, we're not going to use it again, so then it's okay to just reuse it. Okay, I think this should work. Alright, cool, that worked. So to clarify, the issue that I ran into before was that um, I was basically not making a defensive copy, and because of that, there was one child was removing a word, and so that prevented the other branch, which is supposed to be happening in parallel without interference, was actually getting interfered. So now, generally speaking, when you have this issue, there's two ways of doing this. One is that the parent, the callee who is doing the modification, could be made responsible for always making a new copy, and that way it is guaranteed that the parent is not going to do anything weird to muck it up. The other way to do this is for the caller to always pass a new copy to the child, and this way the child can always feel free to make changes to it if it needed. So that's actually what I decided on, which is that the parent is always gonna not trust the child and make a new copy if needed. So over here, for example, words is going to be reused across both the branches. And so for that reason, when you call the first child, you had to make a new copy of the words and the letters. Um, Now for the second one, it's not going to get used again. You can see this is the last time we use letters, and this is also the last time we use words. And because we don't have any other children, we don't mind it being modified, so then we just pass it in without making a copy. And then over here, we do not bother to make a copy anymore because we know that it's the parent will always give to the child something that can be safely modified. So, um, in terms of performance improvements, a couple of things that I wanted to do. First, you can see that right now we're doing this letters.remove. This is actually order n operation, or order 26 operation, because if you want to remove like letter Z, for example, you're going to have to iterate through every single entry in order to get there. Or if you want to remove the last letter, you're going to have to iterate through every single element. So it's actually not even order 26, it's actually order n. So what we could do to make this faster is that we can have a map of character to integer. I apparently can't type. And this way you can have, like, for each character, how many instances of those characters do I have? So this way, when you want to do a remove, you can just do a order 1 operation. The reason I just didn't actually implement it is because you're going to have to deal with, populating the map, populating the zeros, dealing with zero values and defaults and all that stuff. But that is something that I would like to do if I had more time. The character to string conversion, I think ideally you want the letters to be characters, not strings. The only reason I made it string is just so I can copy paste this stuff more easily. So really, not a good reason. It is a pretty simple and poor reason. So yeah, besides those improvements, I don't really have any other big ideas for what improvements can be made. We are using a dynamic cache of word scores because, given a static list of scores, there is no reason for this to ever change, so we can just cache it and reuse it that way. Kind of curious to see if they provide a solution. Do they provide a solution? I don't know how to tell. Yeah, I guess they don't provide a solution, so that is the end of that. I guess I found a solution. Is the better solution? I'm not sure. If you guys have any interest in, coming up with a more efficient solution, not in terms of micro optimizations, to be honest, I don't really care about that, but in terms of big algorithmic complexity, big O. If you find a better solution, do let me know. I'd love to hear more. That's it. Thanks, guys. Have a good day.